Today we're starting the actual 10C course. I told you yesterday that we're starting with chapter 4. We're going to do chapters 4 and 5, and then you'll have your first unit exam. Then we'll do 6 and 7. You'll have a second unit exam. 8 and 9 will be our third unit exam. And then we'll go back and do chapters 1, 2, and 3. And then that'll be your fourth and final unit exam. So the course is split up into 4 units. We don't have a test every unit or every chapter, but every second or third chapter is a unit. Okay? We will have quizzes, at least one, sometimes 2 quizzes each chapter. Those quizzes at the end will count for the same weighting as your assignments. Your assignments are worth 15%. Your quizzes are also worth 15% towards your final grade. Okay? So then your unit exams will count for the rest of your marks as far as what you get reported for each term or each quarter, because we'll have a report card coming up about halfway through, and then one at the end, which will also include the final exam. And the final exam will likely be 20%, because right now that's what the diploma exams are, and so we've always had our final exams weighted the same as the diploma exams that students write in grade 12. Okay, so I said at the beginning, this course is harder than your last math course. It is harder than math competencies if you took that last semester. Some of you did. Significantly harder than Math 9. Okay, there's a huge jump between what you learned in Math 9 and what you're going to learn here. My best advice is to stay on top of things. Do your assignments every day. Okay? There will be some assignments that I'll be collecting for marks. Most of them, though, will not be collected for marks. Those answers will be posted on Google Classroom so that you can do the work and check your answers, make sure you're doing things correctly. I don't just post the answers. I post the steps that I followed to get those answers as well. So you can go through if you get something wrong and see how to do it right. Also remember, if you are away, you can join the class live streamed at the regular time, right? I live stream all the lessons and I also record them. So you can go back and watch those videos if you're not here. You're expected to do that. We're going to go through a lot of stuff every day, and if you don't keep up, you're going to fall behind really, really fast. And it's hard to get caught back up again. It takes a lot of time. Okay, so don't procrastinate. Stay on top of everything, and your chances of success are much better. Remember, I'm here every morning before 8 a.m. if you need help. I'm also here Monday, Wednesday, Thursday, Friday for the first half of lunch. I'm here in case you guys need help with something. And you can also ask questions during the lesson or when it's time that you're working on your homework. So don't be afraid to ask questions. If you're having trouble with something, the sooner you get help, the sooner you can move along and continue forward. Okay? But this is a harder course, so you better be prepared to work. If you want to get the same marks that you got in your last math course, you are going to have to work harder than you did there. Guaranteed. Okay, so this first unit that we're starting with, chapters 4 and 5, is talking about algebra and numbers. So we're going to be talking about polynomials, which we did a little bit of work with polynomials in our review. Exponents, same thing. We went through the basic laws of exponents already. We reviewed them. So we're going to do some more work with them. Plus, we're going to learn some more laws of exponents. We're going to talk about different parts of the real number system. Specifically, we'll be talking about rational and irrational numbers. So you're going to learn what the difference between those are. So that's what this first unit is based on. So let's see if this loads. Yep, it loaded. So I know yours is just a big blank because this is a flash screen, a flash application. So it doesn't, it's an interactive thing. So it works on my screen, but you don't see that. But what we're doing is we're seeing which numbers are perfect squares and which numbers are perfect cubes. So a perfect square. A perfect square or a perfect square is a number that when you take the square root, you get a rational number. So let's talk about what a rational number is. Okay, on the previous page, that's what it said at the bottom. We're going to look at the difference between rational and irrational. So if we just make a note at the bottom of this page, a rational number, a rational number is a number that can be expressed or written as a fraction. So we say in the form a over b, where b cannot equal 0, because you cannot divide by 0. You try to do it on your calculator, you get an error. Okay? So a rational number is a number that can be written as a fraction, basically. That's what that's saying. Okay? And so you all know what a fraction is, right? It's a numerator and a denominator, one number over another. But not all rational numbers are expressed as fractions. Some decimals can also be rational numbers. You can have decimals that are rational numbers. They can be expressed as a fraction. So we can say that this includes both terminating and repeating decimals. If you have a decimal that is terminating, meaning it stops after so many numbers, or repeats, you can write that number as a fraction. So a rational number is a number that can be written as a fraction, a over b, where b can't equal 0 because you cannot divide by 0. And this includes both terminating and repeating decimals. So on a calculator, as a couple examples, if you go 5/8, 5/8 means 5 over 8. It means 5 divided by 8. If you see the fraction 5/8, that's what it means. It means 5 divided by 8. If you do that in your calculator, that's a terminating decimal, 0.625. It terminates, it stops. So the number 0.625 can be written as a fraction, and that fraction is 5/8. That's what we started with. Every terminating decimal can be written as a fraction. Also, every repeating decimal can also be written as a fraction. If you go 2 over 3, 2 divided by 3, that's the fraction 2/3. It is a repeating decimal. Now, the calculator only has room for so many spots to show numbers. And then it rounds off that last number. And that's why the last number here is a 7. Because when you write 0.6 repeating, it's 6s all the way. If you're going to stop it after a certain number and you round it, whatever 6 you're going to stop at, you look at the next digit, which is also a 6. And when you're rounding, if the next digit is 5 or greater, you always round up. You've learned that before. So that's why the calculator shows the last digit as a 7, because it rounded. But 0.6 repeating, that's a repeating decimal. Any repeating decimal can be written as a fraction. And in this case, 0.6 repeating is equal to 2/3. It's a fraction. So as we go through, we will see how you can change terminating decimals into fractions and repeating decimals into fractions. We'll go through that. But for now, any decimal that repeats or terminates can be written as a fraction. So therefore, it is a rational number. And if the decimal doesn't repeat and doesn't terminate, that is an irrational number. The most famous irrational number is the number pi. You would have learned about that. It's used for certain formulas for surface area and volume. Okay, the most basic formula that involves pi is the area of a circle, pi r squared. Pi times the radius squared of that circle will give you the area of that circle. Pi is an irrational number. So most calculators have a pi button on them, and that's the approximate value of pi. We say approximate because that decimal never stops. Again, your calculator has only room to show so many digits, and then it's got to stop and Like we said earlier, it'll round off that last digit. But if you look at these digits after the decimal, there's no pattern there. It doesn't repeat. Okay? And it also doesn't terminate. And normally when the calculator is filled up with decimals like this, it means that it's either it's either repeating or it doesn't repeat and doesn't terminate. Which this number doesn't repeat, it doesn't terminate. This would be an example of an irrational number. You get a decimal, it doesn't repeat, and it doesn't terminate. Now, why are we talking about this? Because on the next page, when we're talking about square roots and cube roots, and we want to know which numbers are perfect squares, which numbers are perfect cubes, a perfect square is a number that when you take the square root, you get a rational number. So that's the definition of a perfect square. A perfect square is a number that when you take the square root, the result is a rational number. And again, when we say a rational number, that means a number that can be expressed in the form a over b. You can write it as a fraction. And as we said on the previous page, that means that it might be a decimal as long as it terminates or repeats. That's a rational number. And then the perfect cube is the same. When you take the cube root of that number, do you get a rational number or an irrational number? If you get a rational number, then that means that that number is a perfect cube. So we can use our calculators to check these. Okay, that first number is 8. So if we take the square root of 8, so all scientific calculators have a square root button on them. Okay, so if you don't have a scientific calculator, I would strongly recommend that you get one. Talk to your parents. You can get one at Staples for probably around $10. You want it to be scientific, which means it has sine, cosine, and tangent on them. And they'll also have the pi button. They'll have square roots. They'll have cube roots. But I recommend that you get your own calculator so that you learn how to use it. Because every calculator is a little bit different. I have some over there that you can borrow, and that's not a problem. Okay? Normally, I ask that you leave something there just so you remember to give my calculator back. A couple of them have disappeared already. So it's just, I know people just forget that they have them. But if you leave something that's of yours there, then that'll help you remember to put my calculator back so you get your stuff back. So please, if you borrow a calculator, just leave something there so you remember to put it back. But if you get your own calculator, then you'll learn how to use it. Okay? And it makes things much easier. Because if you grab a different one over there from what you had the previous time, then you got to figure out where all the buttons are. Because they're not all in the same spot on different calculators. Okay, in most calculators, you'll see an x squared button, and then above it, you'll see a root symbol. Okay, Brock? And so to get that, normally you have to go second function. Like on my calculator, the second function key I needed to turn or hit first to get the radical, and then I put the 8 in there. And then when I hit enter, you see we get a decimal. That decimal does not repeat, it does not terminate. Again, your calculator only has so much room to put numbers in there. This calculator screen is filled up as far as it can. There's no more room for any other numbers. That's the most number of digits that it'll show. So this is an irrational number because the decimal doesn't repeat, doesn't terminate. So therefore 8 is not a perfect square because the square root is irrational. What about the cube root? So again, on my calculator, I hit the math key, and then number 4 in the list is cube root. Most scientific calculators will have a place where it says x root. Most scientific calculators will have that, x, and then a root. And so in that case there, you'd put the 3 in first, hit that x root button, and it'll take the cube root of whatever number we put in. Okay? So again, if you have your own calculator, you'll learn where all these things are. And we see that the cube root of 8 is 2. It's not a decimal at all. You can write that as a rational number, 2, by saying it's 2 over 1. You can write it as a fraction, 2 over 1. It's a rational number. So therefore, 8 is a perfect cube. Okay? 169. So let's check that. Actually, let's do it this way. Let's take the square root of 169. Equals 13. It's not a decimal at all. That's a rational number. You can write it as a fraction if you want to by going 13 over 1. So 169 is a perfect square. The square root of that is a rational number. 1,000. If we take the square root of 1,000, rational or irrational, Brock? Why? Yes, perfect. Doesn't repeat, doesn't terminate. That means that is an irrational number. It means the square root of 1,000 is not a perfect square. It might be a perfect cube, though. So let's check this. The cube root of 1,000 is actually 10. That's a rational number. It can be written as a fraction if you want by going 10 over 1. So that is a perfect cube. 125, take the square root. Allie, is 125 a perfect square? Why not? That doesn't terminate and it doesn't repeat. And that's right, you could not write it as a fraction. In order to write a decimal as a fraction, it would have to either repeat or terminate. This one doesn't do either. So therefore, 125 is not a perfect square. Let's check to see if it's a perfect cube, and we're going to see that it is because the cube root of 125 is exactly 5. That could be written as a fraction, 5 over 1. So 125 is a perfect cube. 225, take the square root. Cheney, is that rational or irrational? Which means you can write it as a fraction. What would that fraction be? Yes. Okay. If we tried to take the cube root of 1 or 225, try this again. Cube root of 225. Is 225 a perfect cube, Brooklyn? Why not? Why can you not write that as a fraction? How do you know it's not a rational number? But we've seen decimals that are rational. What about this decimal makes it so that it's irrational? Right? Or it also doesn't terminate. That's how we know. So 225 is not a perfect cube, and if we tried to put the 225 up there, won't let us because it's not a perfect cube, it's a perfect square. And some of these you may know already by looking at it. You might know that 27 is not a perfect square. You might remember that the square root of 25 is 5 because 5 squared is 25. The square root of 36 is 6 because 6 squared is 36. This number 27 is between 25 and 36. Two perfect squares. 25 is a perfect square because the square root of that is exactly 5. excuse me, 36 is a perfect square because the square root of that is exactly 6. 27 is in between 25 and 36. So it's probably not a perfect square, but we can certainly check it easy enough to make sure. And you get a decimal that doesn't repeat, doesn't terminate. So therefore, 27 is not a perfect square, but we're going to see that it is a perfect cube because the cube root of 27 is 3. And you can write that as a fraction if you want, 3 over 1. 27 is a perfect cube. 625, if we take the square root of that, whoops, try that again, there we go. It's a perfect square. But if we try and take the cube root, you get a decimal that doesn't repeat, doesn't terminate. So 625 is not a perfect cube, it's a perfect square. Is 16 a perfect square? What's the square root of 16? 4. Okay, I'm sure most of you know that. That's a perfect square, but if you try and take the cube root, you'll get an irrational number. 81, does anyone remember if that's a perfect square? That's right, the square root of 81 is 9. If you try and take the cube root of 81, you get a decimal that doesn't repeat, doesn't terminate. It's not a perfect cube, only a perfect square. 256 is a perfect square. The square root of that is 16. But if you try and take the cube root, you get a decimal that doesn't repeat, doesn't terminate, so it's not a perfect cube. 121 is also a perfect square. The square root of that is 11. But if you try and take the cube root, you get a decimal that doesn't repeat, doesn't terminate. So therefore, that's irrational. It's a perfect square, not a perfect cube. 512. If you try and take the square root of that, you get that decimal. Now that decimal is a little bit shorter than some of the other ones we saw. Some calculators have a function in them that will turn decimals into fractions, and mine does. If I go into the math again, you see the very first choice here is number 1, arrow fraction. That means take the number that you have in your calculator and turn it into a fraction. So if I choose that, that tells me it can't be written as a fraction. Otherwise, the calculator would have given us a fraction. Okay, so just to see how that works, if you have 1 over 3, that's a decimal, 0.3 repeating. The calculator will turn that to a fraction. It'll go back to 1/3 by doing the same thing. Hit the math key on this calculator and then enter, and it writes it as a fraction. So some calculators have that function in them. When you're looking for a calculator, it would probably be good if you found one that had that. Again, it's a scientific calculator. You can probably get one for about $10 at Staples. So we've seen that 512 is well, we saw that it's not a perfect square, but let's check to see if it's a perfect cube now. And it is. The cube root of 512 is 8. So what does that mean? When you take the cube root of a number, you're finding what number times itself 3 times gives you that answer. The cube root of 512 is 8, and that means that 8 times 8 times 8 is 512. The cube root is asking, what number multiplied by itself 3 times gives you that original value? So again, this means that to get 512, you'd go 8 times 8 times 8. And you could check that. 8 times 8 times 8 does give us 512. Right, so this is a perfect cube. Is 25 a perfect square? What's the square root of 25? Yes. What about 9? What's the square root of 9? Yes. 216, let's check that. I don't think it's a perfect square. Nope. So let's check about a perfect cube. And it is. The cube root of 216 is 6, which means 6 times 6 times 6 is 216. 343. I don't think that's a perfect square. Nope. But let's check to see if it's a perfect cube. And it is. Cube root of that is 7, which means 7 times 7 times 7 will give us 343. There are some numbers that are both perfect squares and perfect cubes, Brock. Yeah, what? Huh? What? What? I don't know. What's your middle name? William. And who you named after? Dad, grandfather? Nice. That's nice. Okay? There are some numbers that are both perfect squares and perfect cubes, and I think I remember one of those numbers is 4096. It is a perfect square. And if we try and take the cube root, okay, there are some numbers that are both perfect squares and perfect cubes. 4096 is one of them. All right, so we've talked about the difference between rational and irrational, perfect squares and perfect cubes. One of the uses of square roots, perfect squares, is dealing with area. If you're given the area of a square and you want to find the length of each side, that can be done by taking the square root of the area. And here's the reason why. The area of a box is length times width. A square is a special box where all the sides have the same length. So if we say that S represents the length of each side of a box, the area of that box, that square, would be S times S, which we could write as S squared. The area of a square is the length of each side squared. Okay, Jan? But if you're given the area and you want to find out what S is, we can take this equation that we just wrote and get S by itself by getting rid of the squared. Now, when we just did all our work last couple days with solving equations, we did the opposite operation to get a variable by itself. We're going to do the same thing here, only now we're going to do the opposite of squaring, which is square rooting. If you take the square root of both sides, on the right side, the square root of S squared will just be S. The square and the square root cancel each other out. And on the left side, you're going to have the square root of A, the area. You can find the length of each side of a square if you know the area by taking the square root of the area. So this is one application of square roots. Finding the length of a side of a square if you know the area. And so in this case here, the length of each side of that square would be the root of the area, or the root of 121 feet squared. Area is always in units squared. Okay? So that's why it says feet squared or square feet. What that means, if this was an actual box, an actual square with that area, what that means is that you have to take 121 small squares that measure 1 foot by 1 foot, 121 of them to cover that shape up completely. Exactly. There wouldn't be any overlap, there wouldn't be any pieces missing, not covered up. 121 square feet means, for an area, it means that if you had boxes or small squares that measured 1 foot by 1 foot, it would take 121 of them to cover that square up completely. But we want to find the length of each side, and as I said, you can do that by taking the square root of 121, which is 11. 11 feet. And that's the answer for the length of each side. And you get it by taking the square root of 121. So the second one is the same, right? If you have the area of a square to be 9 centimeters squared, and you want to find the length of each side of that square, once again, it's the square root of the area. In this case, it'll be the square root of 9 centimeters squared. Again, that's the area of the square. And so what that means is if you had little squares that measure 1 centimeter by 1 centimeter, it would take 9 of them to cover that shape up completely. But we want to find the area, we want to find the length of each side, given the area, and the square root of 9 is 3. And you're also taking the square root of centimeters squared, which gives you centimeters. So again, that's one of the applications of square roots. If you have the area of a square, you can find the length of each side by taking the square root of the area. These next ones, though, deal with volume. Right? For area of a square, that's a two-dimensional shape. You can draw it on a page, and it's just flat. But when we start talking about volume, volume is how much fits inside of an object. And you need a three-dimensional shape in order to be talking about volume. So that's why these are drawn as boxes. And these would be cubes, meaning that the length of the dimensions are all the same. The width will equal the length, and it will also equal the height. All three dimensions are the same. And to get the volume of a box, it's length times width times height. Or in this case, it'll be S times S times S, or S cubed. The volume of a cube is a special box where the length, width, and height are all the same. The volume can be found by cubing the length of one edge. And if you are given the volume and you want to find out what S is, we'd have to solve this equation for S. We'd have to get rid of the cube by doing the opposite of cubing, which is cube rooting both sides. On the right side, cube and cube root cancel each other out. So you'll just be left with S on the right. And on the left side, you'll have the cube root of the volume. So this is one of the applications of cube roots. If you have the volume of a cube, which is a special box where all the side edges are the same, you can find the length of each side edge by taking the cube root of the volume. So for this question here, if you're told the volume is 8 cubic inches, okay, so what that means is that in order to fill that box up completely, you would need 8 smaller boxes that measure 1 inch by 1 inch by 1 inch. 8 small cubes that measure 1 inch by 1 inch by 1 inch. It would take 8 of them to fill up that box. That's what it means. But if we are given the volume and we want to find the length of each side, we'd have to take the cube root of the volume, the cube root of 8 inches cubed, and we saw earlier that the cube root of 8 is 2, and the cube root of inches cubed is inches. That's the length of each edge of that box, 2 inches. That box would be 2 inches by 2 inches by 2 inches to give a volume of 8. And for the second one, again, the length of each side edge is the cube root of the volume. In this case, we're told the volume is 64 meters cubed. And so the length of each side edge would be the cube root of that. And the cube root of 64 is 4. You can do it on your calculator. But not only are you taking the cube root of 64, but also the cube root of meters cubed to give you meters. So again, that's one of the applications of cube roots. If you have the volume of a box, the cube root of that volume will give you the length of each edge as a dimension. So this next page, evaluate each of the following, Jan. You have to stay with us. Okay, up you come. So in this case, for question A, I mean, you can do this one of two ways. Normally, you'd probably look at that and say, well, I'm going to multiply the 64 and the 27 together first, and then take the cube root of that 1728 that we got when we multiplied those two together. And so if we go back to our calculator and take the cube root And so my calculator has a previous answer key on it, answer function. So that's what I did there instead of typing in 1728. So again, if you look and see if your calculator has an ANS button, it's right there on the bottom of mine above the negative sign or negative key. That's where mine is. So I get an answer of 12. Now, I'll show you that this is actually the same thing as the cube root of 64 times the cube root of 27. You can do it this way as well. Instead of multiplying the two numbers together and then taking the cube root, you can take the cube root first and then multiply those together. The cube root of 64 is 4. The cube root of 27 is 3. And if you multiply the 4 and 3 together, you get the 12. So either way it works. Either way. Okay? So the answer there is 12, and I think it tells us to drag the answer up there. So that's the answer to that one. The next one, the cube root of 125a cubed. So you have to do that in two parts. The first being taking the cube root of 125, which we already saw is 5. But you're also going to take the cube root of a cubed, which would be a. So the answer to this one would be 5a. So we can drag that one up there. Question C says the square root of 9/16. Now, you could go 9 over 16 as a decimal. And then take the square root of that after. So the square root of the previous answer, 0.75, which you may know, that's the same as 3/4. And my calculator, if I go math, enter, will turn that into a fraction. But I also could have taken the square root of the top and the bottom. The square root of 9 is 3. The square root of 16 is 4. So there's another way you could have gotten that answer. Just take the square root of each number. Question D, you're squaring 3 and 4. And I would square the 3. 3 squared is 9. Over 4 squared is 16. The answer is 9/16. That's a rational number, right? We can get it as a fraction. And you see that it's a terminating decimal. It stops after 4 numbers, which means it can be written as a fraction, but we already knew that. The fraction is 9/16. So for question E, I would take the cube root of both 8 and 27. The cube root of 8 is 2. The cube root of 27 is 3. And so that gives us 2/3. Again, if we did this in our calculator, took the cube root of 8 over 27, it would give it to us as a decimal. 0.6 repeating. Because it's a repeating decimal, it can be written as a fraction. Calculator gives us the 2/3 that way. Okay? On to the next page. So we've talked about square roots and cube roots, kind of what they are. We're going to determine the square root of a perfect square as well as the cube root of a perfect cube, and then we'll look at some problems involving square roots and cube roots. We said that the perfect cube is a number that is a product of 3 equal factors. For example, 64 is 4 times 4 times 4, or 4 cubed. That's why the cube root of 64 is 4. The cube root is one of the 3 equal factors of a number. So perfect cubes and cube roots are related to each other. The number 27 is a perfect cube that's formed by multiplying 3 factors of 3 together. 3 times 3 times 3, or 3 cubed, is 27. So therefore, the cube root of 27 is 3. As it says, some numbers are both perfect squares and perfect cubes. 64 is one of them. I used 4096 earlier, but 64 is also both a perfect square and a perfect cube. So this first example says identify whether each number is a perfect square, a perfect cube, both, or neither. And so you just use your calculator for this. If you take the square root of 121, it's exactly 11. But the cube root of 121 is an irrational number. It's a decimal that doesn't repeat nor terminate. So therefore, 121 is a perfect square only. 729 is a perfect square. Checking whether it's a perfect cube. Turns out it is. So therefore, this is both perfect square and a perfect cube. 356 is not a perfect square and not a perfect cube either. So this one is neither. Okay? So try those ones on your own. Use your calculator. Yes, sir. Yeah, make sure you sign out 5 minutes or less. I think you should have gotten that A is a perfect cube. 196 is a perfect square. I think the square root of that is 14, if I remember correctly. Yeah. 4096 is the one example I showed you earlier that was both a perfect square and a perfect cube. Now, over on the right-hand side, it says you can use prime factorization. That's the process of writing a number as a product of its prime factors. And you can use this to also see if a number is a perfect square or a perfect cube. So let's see how this works. Let's take that number 196 and let's break this down to a product of its prime factors. So prime numbers are numbers that have only two factors. Factors are things that multiply together to get what you start with. Okay? The factors of 6 are 1 and 6 or 2 and 3 because you can multiply those numbers together to get 6. Prime numbers, again, have only two factors, the number 1 and the number itself. The first prime number is the number 2. The only thing you multiply together to get 2 is 1 times 2. The number 1 and the number 2 itself. The next prime number is 3, because the only thing you can multiply together to get 3 is 1 and 3. The number 1 and the number itself. 4 is not prime, because you can go 1 times 4 or 2 times 2. It's a composite number, has more than two factors. But 5 is prime. Only 1 times 5 multiplies together to get 5. So we want to take the number 196 and break it down to prime factors. So when you look at that number, the first thing you should realize is that 196 is an even number because the last digit is even, which means it's divisible by 2. If you go 196 divided by 2, you'll get 98. So you can break 196 down to 2 times 98. 2 is a prime number, but 98 is not. 98 can be broken down. Again, the last digit is even, which means 98 is also divisible by 2. And that's 2 times 49. So now I've got 2 times 2 times 49. If you multiply 2 times 2 times 49, you'll get 196. But we're not done because 49 can be broken down to 7 times 7. Now we're done the prime factorization. 7 is a prime number. The only thing that multiplies to get 7 is 1 times 7. So how can you use it to show that 196 is a perfect square? Well, here's how. I'm going to group together parts that are equal. I've got 2 2s and 2 7s. Okay, so I can put the first 2 and the first 7 together. I can put the second 2 and the second 7 together. 2 times 7 is 14. So this shows that 196 is 14 times 14. So the square root of 196 is 14. That's asking what number do you multiply by itself to get the original answer. 14 times 14 is 196. So you can use this to determine perfect squares. Now you normally wouldn't because your calculator does it for you. But you could do the same thing for a number that's a perfect cube. Okay? Only you'd have to get 3 equal expressions instead of 2 equal expressions on the bottom. Okay, but again, we're using our calculator for that always, so I just wanted to show you that because it does talk about it on the top right there, about using prime factorization. But we wouldn't do it that way. We would use our calculator, right? And we've already done those questions above there. So on to the next page. So we'll look at a few problems involving square roots and cube roots. The uranium that Saskatchewan produces in a year has a volume of about 512 meters cubed. If this volume were made into a single cube, what would be the dimensions of that cube? So we know that the length of each edge of a cube can be found by taking the cube root of the volume. We developed that formula earlier. And I think we might have used S instead of L. It doesn't matter. S for the length of each side, L for the length of each edge. It doesn't matter. But in this case here, you're given the volume to be 512 meters cubed. And if we take the cube root of that, it's exactly 8. And the cube root of meters cubed is meters. So if they took all that uranium that Saskatchewan produced in a year and formed it into a giant cube, that cube would be 8 meters by 8 meters by 8 meters. It would be a box with a length of 8 meters, a width of 8 meters, and a height of 8 meters. Looking at the one at the bottom, a floor mat for gymnastics is a square with an area of 196 meters squared. What is its side length? Well, we saw earlier that the length of each side of a square can be found if you know the area by taking the square root of the area. And in this case, the area is 196 meters squared. You take the square root of that, you're going to get 14. And the square root of meters squared is just meters. So that's the answer. That's the length of each side, 14 meters. B says the volume of a cubic box is 27,000 inches cubed. It says use 2 methods to determine its dimensions. So method 1 would be just using the calculators. The length of each edge we've seen is the cube root of the volume. Or in this case, the cube root of 27,000 inches cubed. So the cube root of 27,000 is 30, and the cube root of inches cubed is inches. So 30 inches would be the answer for the length of each edge. So its dimensions would be 30 inches by 30 inches by 30 inches. Now our second method would be using prime factorization. So you're never going to be asked to do this on a quiz or a test, but let's do it because it asks us to do it a second way. So 27,000. The last digit is 0, which means it's an even number. It means it's divisible by 2. So if you divide 27,000 by 2, I think that's 13,500. Yep. So there's our first step. And 13,500, last digit is 0. It's an even number, so that's also divisible by 2. You can divide by 2 again. 6,750. So we have 2 times, this is 2 times 6,750. And 6,750 is even, so we can divide that by 2. I think if I just hit enter, it'll keep doing that. Yeah, keep repeating the same process. 2 times 3375. So let's carry this down here. 2 times 2 times, this was 2 times 3375. So that number is not even because the last digit is a 5, not an even number. But because the last digit is a 5, that means it's divisible by 5. So now we'll divide by 5. 5 times 675. We've got 1, 2, another 2, another 2, and now we have 5 times 675. 675 is divisible by 5 because the last digit is a 5. So let's divide that by 5. It'll be 5 times 135. So I've got 2, 2, times 2 times 5, and I broke this down to 5 times 135. I think, if I remember correctly, yep. And 135, last digit is 5, so that's divisible by 5. It'll be 5 times 27. And just to save time, 27 is 3 times 3 times 3. Now I've written that number as a product of its prime factors. All those numbers in the bottom are prime numbers. They have only 2 factors, the number 1 and the number itself. To show then that the cube root is, what do we get, 30? If you look at this, you can write 3 equal groups. There are 3 2s, 3 5s, and 3 3s. So you can have a 2, a 5, and a 3 as one group, a 2, a 5, and a 3 as a second group. Now we've used 2 of each, so we have one more group of 2 and 5 and 3. 2 times 5 is 10, times 3 is 30. That's 30 times 30 times 30. This shows you that the cube root is 30, because you can write 27,000 as 30 times 30 times 30. Again, you would use the calculator to get the cube root of 27,000, but prime factorization works as well, which you could use if you didn't have a calculator. Okay? So we've seen what perfect squares are, we've seen what perfect cubes are, and what they're used for. Note down here, you can take the cube root of a negative number, but you cannot take the square root of a negative number. If you try and take the square root of, say, negative 16, you get an error. Because when you take the square root of negative 16, you're asking what number times itself gives you negative 16. Whenever you multiply a number by itself, the answer is always going to be positive. It's either a positive times a positive or a negative times a negative. Both give you a positive. But if you multiply a number by itself 3 times and they're negative, your answer is negative. Negative 5 times negative 5 times negative 5 is negative 125. So as it says there, the cube root of negative 125 is negative 5. You can take the cube root of a negative number, not the square root. Okay, we saw that you can use diagrams, manipulatives, factor trees, or calculator to find the square root and cube root of numbers. Okay, so what I want you to work on for homework is page 158 to 60. I think these questions are in your package. You don't have to even get your textbook out. Question 8, 9, 10, 12, 14, and 16 through 18. I will be posting these solutions to Google Classroom so you can check your work. Again, I encourage you to do this. Check your answers. Make sure you're doing things correctly. If you get stuck, you can look on Google Classroom. I'm going to post the solutions. Not just the answer, but how I got it. But if you have questions about anything, ask. Something doesn't make sense. So I strongly encourage you to do these questions and check your answers. I'll be posting those to Google Classroom. Okay?